Hi there, my name is Rob Verkerk, the Scientific and Executive Director of the Alliance for Natural Health International. I'm going to now give you essentially the same presentation that I gave last Sunday at the 13th European Congress for Integrative Medicine. It was a keynote address in the Planetary Health session on the Sunday afternoon. And essentially what it is looking to see if we can explore a unified and coherent approach to looking at two of the biggest problems that we currently face relating to both the state of the planet ecologically and human health. Typically what we've seen is entirely different approaches to both these problems. They're often technologically driven. They're quite divorced from nature. So in essence, what we're seeing in terms of sustainability problems is humans basically raping the planet, overusing ecosystem services to the point that they cannot be replenished. They go beyond their natural capacity for sustainability. This was very well put by Patricia Howard back in 2014. The question is that many of these same principles in terms of resilience also apply to human health. So let's just have a look at two of the biggest problems that we face today, that generally are scoped in a very specific way. So the ecological crisis, planetary crisis that we face is generally referred to as a climate change problem. From a human health point of view, the issue that has dominated so many people's lives is obviously COVID-19, the arrival of a new virus. And in essence, we're told that the way to solve climate change is to reduce carbon emissions around the world. In terms of the COVID-19 pandemic, we're told that if we engage in a mass vaccination program, global mass vaccination program, using synthetic biology vaccines that have never been deployed at scale on human populations, that use a very specific spike protein receptor binding domain antigen, we will walk away from these problems. And of course, in both cases, what we see is this consistent failure of seeing anything that even approaches a solution. Some of that is down to the problem. How do we define the problem? Are we agreed what the problem is? Is there consensus around this? And do we have enough people pulling on the same kind of levers to really make a difference? And I would argue that in essence, the problem is very much wider than we're often led to believe. It is much wider than a climate change problem. It goes right to the core of looking at, how human beings are living on planet Earth. The very fact that we know that if we can plant more trees and improve the ability of terrestrial ecosystems and marine ecosystems to absorb carbon dioxide, we will actually overcome the problem, which by definition means that reducing carbon emissions is only part of that problem. But we've got to look at the fact that we're in the middle of this massive mass extinction, the sixth mass extinction the planet has seen. So a biodiversity crisis, which often gets to play second fiddle alongside climate change. And when you look at the amount of habitat destruction, we have to start looking at the way in which we use land. And just, for example, reducing red meat consumption and growing a lot more cereal, which is still very dependent in non-organic agriculture, dependent of high inputs of NKP fertilizers and herbicides like glyphosate. We see a destruction of the soil microbiota, which is critical in terms of acting as a carbon sink. But at the end, what we see is this non-compatible human lifestyle, as well as very specific traits of human beings, this desire for growth and affluence, and also the way in which power play works out between different groups of human beings. So we see then a battle of vested interest, trying to do what works well for them, but not necessarily the planet or other people. Similarly, when it comes to the COVID-19 pandemic, we've got to determine whether this is a pandemic really all about a virus, or whether it is a deficiency in the human terrain. We've seen very strong evidence of comorbidities, people with metabolic dysfunction, immunological dysfunction being the ones that suffer the most serious COVID-19 disease. And also we've seen very clearly that people who have dysfunctional innate immunity, children and young people come into this world with very strong innate immunity. They have strong innate immunity. It means they're well protected. Obviously, we have to look at the way in which vaccination can interfere with that. It is a problem. And of course, we see this dysregulation in the super system between our psychological, neuro, and immunological systems. We also see that people who suffer preventable lifestyle-related metabolic diseases like type 2 diabetes, obesity, suffer some of the worst outcomes. And similarly to the climate change ecological crisis, we see that it's inappropriate lifestyles, particularly in industrialized society, and this human desire for growth and affluence and greed and power that actually drives many of the problems. So how far upstream do we want to look to try and resolve these problems? This is just a reminder from PLOS One that comorbidities are the real drivers in COVID-19. And there hasn't been a lot of talk. There's certainly been not enough talk on how we might address those problems in the longer term to really create more resilient individuals and communities. We did our own analysis last year that looked at all the various factors that contribute to a high risk of severe COVID-19 disease. We isolated 52 different factors, and we looked at those that were modifiable or possibly modifiable and generally not modifiable. And you'll see that the area of metabolic health and health generally, as well as nutritional factors and even some disease factors, are modifiable. And so we could be doing a lot more. The reason why these haven't become part of the primary narrative, if you like, part of the solution, is because they don't necessarily make money for particular corporations. Ultimately, we've got to be looking at resilience, not just at health, but at resilience, both from a planetary perspective and a human health perspective. And it's useful to look at these three levels of adaptation to stressors. We have at the lowest level, when the stressor isn't too strong, we have this ability to absorb and cope with mild stressors and shocks to the system. In the middle, we see adaptive capacity, where we need some flexibility, but right at the edge of it, we see the system being pushed to such an extreme that it has to transform in order to be able to adapt, or it breaks. And so right now, we're at this tipping point at which systems are starting to break because of the fact that they're not well adapted to the amount of stress that's being placed on them. Ultimately, in a balanced system, there are always stresses within the system, but the feedback loops and interactions within it create this stability that comes out of complexity. And ultimately, we as one species on this planet are poorly adapted to our modern lifestyles. That's one of the reasons we suffer such major burdens of preventable lifestyle-related diseases. But equally, the planet isn't well adapted to this one species that does things in a different way, that is prepared to try and look for technological solutions, is trying to increasingly alienate itself from the system from which it originated. And that's creating many of the problems we see. While it's helpful to look at complexity as a system and move away from a kind of linear way of evaluating a problem, we should recognize that a process may still be linear, and there is a continuum between outright sustainability and outright failure of sustainability, collapse of that system, whether it's a human ecosystem or a planetary ecosystem. And along the way, you'll see that many of the things that we engage with create such pressure on the system that ultimately it breaks. It takes it through this absorptive and adaptive and then transformative point. So unless we transform sufficiently and really change, we cannot tweak around the edges anymore. We have to fundamentally change the way that humans live on this planet to be able to address this habitat destruction, mass extinction, of which climate change is part of the problem. And if you look at any aspect of human health, mental health is now in crisis because of the pressure that human beings are under. And of course, over these last 2 years, that pressure has been extreme. So we see, again, this increasing pressure being put on the system until we hit that transformative capacity, we hit that tipping point, and then people are pushed into a permanent state of pathological illness, mental health illness in this case. Moving back to the climate change model, this is a video from the United Nations that reminds us what the narrative that we're being given is all about. And here we are told over and over again, the only way to limit this rapid climate change is to decrease our collective emissions quickly. You remember at the outset we said, well, we've been being told we have to reduce CO2 emissions, but we're not being told very much about how we might improve the ability of terrestrial marine ecosystems to be better carbon sinks. And of course, when you look at the second screen grab, you'll see that the UN is also saying, but countries are not able to agree who is responsible and who should bear the heaviest load. So the bottom line is you could engage in this cyclical conversation in which there is no agreement while a crisis is occurring and nothing is happening. And that's why we're so far away from agreeing the emissions that were agreed at Paris in 2015 in COP21. And we will continue to debate and not address the system as a whole and looking at all the various levers that could be played upon. So here's Leroy Hood, who many of us have followed for many times, the father of P4 medicine, and he reminds us that healthcare today is all about disease. It's not about understanding the flip side of disease, which is wellness. These are completely different issues. So at the moment, the healthcare system that we refer to as a healthcare system is a disease management system. We're looking at markers of disease. We're not looking at markers of health. Ultimately, good health, whether you're looking at the ecosystem of the planet or the ecosystem of human health, is all about the terrain. How these systems and super systems interact with one another. It would be very helpful to do more sensitivity analysis to understand better which parts of the system are more sensitive to change than others, so that we can start to work together on applying similar levers to have more impact. We have to recognize that the microbial world underpins everything. It is the system that provides stability to all systems, and in a human being you'll see that in terms of the gut microbiome. In an agricultural system you'll see it particularly in relation to creating living soils that are very rich in terms of their microbiota, the bacteria and the fungi, and of course when you look at complex ecosystems like a rainforest, this is a three-dimensional ecosystem which has 4, 5, 6 different trophic levels that need to all be there in order to provide stability in the system. We have to also think about, from an epigenetic point of view, how the environment begins to change gene expression, not just in the human being, but also in all animals and plants. And Waddington showed us the canalization issue that I'll show in a minute or two. We also need to consider that we are part of nature. We're born out of nature. So therefore, trying to find solutions that are just technological, that ignore the way in which humans should operate as one species that exists within a much wider ecosystem, is always going to be problematic. And therefore we have to perhaps reconsider the role of technology. It's unlikely that we will see magic bullets of technology delivering solutions for either the planetary crisis. We might be able to deliver new technological systems that provide greener energy, but that doesn't instantly deal with the habitat destruction. So we need to change social systems as well. And obviously in relation to human health, we're seeing at the moment the potential failure of the primary technological solution that was offered to us. So this is a reminder of Waddington's well-known 1957 depiction of how epigenetics works. You can see a marble rolling down a slope here into various valleys, and depending on which direction it goes in, those valleys, that environment, will leave certain epigenetic marks created by methylation and histone modification. The deeper you run into particular valleys, the harder it is to move to another one. So we have to be very sure of the track that we're in, otherwise it can be an unsustainable mission to try and, if you like, change track. We're used to thinking about environmental, social determinants of health. And of course, this is this combination of various factors: physiological, genetics and epigenetics, psychosocial, emotional function, and environment. But is that all we need to look at? And how far upstream? Remember, these are dynamic systems. So the way in which the environment plays on gene expression, even prior to birth, has an influence over a lifetime and may even have intergenerational influences. So we've got to look at the big picture. We all know what happens when lights on a dashboard of a motor car, even an old motor car like this, go on. We know that there's the beginnings of a problem with function. It may be that the oil is low, but the engine hasn't yet blown up. What we need is a universal language. What's really limiting our ability to find solutions both to planetary health and human health is a lack of a universal language. We very easily get swayed into a conversation about a particular part of the system that often benefits particular players, particular vested interests, but we don't generally have an ability to see the complexity of the system as a whole. And obviously, as we move to more and more complex systems, here's an aircraft, but of course, ultimately the human being is the most complex system we know about. And this is just from the University of Luxembourg, the virtual metabolic human, looking at the 135 pathways that control human metabolism. So we could easily spend more time looking at when certain pathways become dysfunctional and see if we can address them before the human being breaks down, before it crashes. And of course, at the moment, the healthcare system is basically a crash repair shop. It's a reactive system that comes into play when the engine, when the human being as a machine has broken down. And of course, that makes it very difficult to reverse disease. We often have complex diseases with many comorbidities. And of course, in the case of COVID-19, what that does is make us much more susceptible to infectious diseases. And obviously, it has all sorts of societal impacts financially on the healthcare system, on productivity. So there's a huge price to pay. What we need to understand better if we're going to apply sustainability to healthcare is how to move to a more proactive system that it exists throughout an individual's lifetime. Right at the heart of that problem is the fact that we have a system currently that's set up to, in terms of hospitals and clinics, structures that deal with the breakdown. They're not good at looking at the orange lights or the red lights on the dashboard to take action, evasive action, to modify lifestyles, behavior, and environment. to generate health during a lifespan. And that's what's needed. And the difficulty is when you're out in the community there, at the moment there isn't even a common language that ties all of this together. So people just follow public health guidance, which often conflicts, and they hear what newspapers say, which often has a vested interest behind some of that messaging. So how do we develop a universal language? And really systems ecology becomes one of the underlying principles that always applies. So we need to move away from just thinking of health and thinking more of resilience. We need to be thinking about function and interactions and feedbacks and responses to stress. And these are things that are not ordinarily considered within health management, health creation, and certainly not disease management. So people don't generally go to their primary care physician and get either tested or asked about their resilience or their flexibility, whether it's physical, intellectual, emotional, social, metabolic, neurological, or even immunological. It helps to have three lenses, not just one lens, that uses evolution as one lens, because we need to understand from where we've come, ecology that understands that we are organisms that interact not only with each other but also with all parts of our environment, the biotic and abiotic parts of it, and also that there are multiple systems within systems, whether we're looking at molecular interactions, the interactions between molecules, genes, cells, organs, and organisms, but these are systems that interact with each other. So we need to be thinking big and using these three different lenses. And of course, laid upon that, we also need to understand how our behavior and environment changes the expression of our genes. We have a couple of hangovers to deal with. Louis Pasteur and Robert Koch, very focused on pathogens, external sources of disease, rather than looking at the terrain itself. And we need to move away from the idea that was born out of Pasteurian and Koch thinking, which is that there is one cause to each disease. Of course, there are multiple causes, particularly when you start to look upstream. So we have many. If we look at most of the burden of chronic disease, it is the result of often decades of systems running below par until they start falling apart. We see clinical symptoms of disease, and then only then is action taken. So that's not a great way of doing it. The WHO, for example, understands this extraordinary burden of chronic disease, but when it looks at causes of chronic disease, we're not convinced that it's really dealing with the proper upstream causes that are related to all these cultural, social, and environmental determinants. For example, taking the issue of a population in the industrialized world that's getting ever more fat, sick, and tired, you can address a whole range of problems that relate to what, when, and how we eat, when and how we move, our insufficient capacity for being able to handle and cope with stress, as well as our toxic burdens. And of course, there are so many data that support all of the various bullet points that I've got pictured here. And because this is complex, for many people, it's just easier to take a pill. But actually what we need to find is ways in which, as with any system, that you undertake actions that bring together lifestyles that automatically address many of the things that we're doing wrong. But you need to understand the system properly to be able to do that. And it's very helpful here to take the perspective that Egger and Dixon show us from back in 2014. At the moment, looking at the right-hand side of this diagram, you'll see that from any disease, we generally are told we need to look for risk factors of those diseases and address those. But how far upstream do you go? So here we can see that there is a a cause or a cause of the cause, or even a cause of the cause of the cause. And if I take an example, go again to the right hand side of type 2 diabetes, you'll see that many people are being checked for their glycated hemoglobin levels, their HbA1c levels, that is viewed as a key long-term marker of type 2 diabetes risk, and that's related to metabolic syndrome. They may even recognize that metabolic syndrome is related to a poor diet, but when you go sufficiently upstream to this distal upstream cause, in this particular case, you may find that actually it was an individual's child trauma that made it impossible for them to consume a good diet, that set up behavioral patterns and adaptations that led them to eating a junk diet and not in the right way and not exercising sufficiently, that drove the metabolic syndrome. So this really is a reminder of how far upstream we need to be looking at to address one of the biggest health crises we face. Obviously, it gets more and more complex and, of course, more and more distant from that individual. So we have societal, social and environmental solutions we need to look to. But you'll see that in this particular case of obesity, what we see is that, and actually that applies to all chronic degenerative diseases, that they're underpinned by this systemic inflammation or meta-inflammation. And so we have to find ways of, economically, politically, socio-culturally and physically at looking as far upstream as we can to ensure that these downstream causes don't occur. Otherwise, we're just sticking our fingers into the dike, if you like. Here we see a classic categorization of the key diseases. But again, when you start to look upstream, you'll see that there are a relatively narrow range of factors that really apply to all those diseases. So again, a reminder of how far upstream we need to be looking. Healthy dietary patterns, regular moderate physical activity, stress tolerance, healthy environments, positive relationships, purpose and meaning in life. And then in doing that, we address these key markers for chronic and degenerative disease that are about systemic inflammation, excessive oxidative stress, dysregulated immune systems, and poor patterns of gene expression. So these are things we can address now, we can look at. But how do we do that? This is the Mikirch model from Switzerland that divides a human's demands of life into these various components and that relate to the individual, society and environment, and it allows the individual to look at 5 components and 10 interactions. And it's particularly interesting to look at this relationship between biologically given potential and personally acquired potential, that while we might come into this world with a high potential, say 100% at birth, and it's 0% at death, we can do an awful lot during our lives to counteract that deterioration in biologically given potential by adapting better to the environments that we have, learning how to live healthier lives. But again, this is a useful tool for clinicians to use to address where are you at with each of these interactions. And we have been looking at how do we apply an ecological language to the human ecosystem. And here what we do with our ecological terrain is divide the system into 12 different domains, each of which can be measured according to function. And we can do this both from a, if you like, a biomedical testing point of view, but we're also looking at proxies for this that an individual can follow at no cost, that give an indication of where function in that particular domain is. Because if you have good function, when you're trying to create health and you have good function across all 12 domains, you have an environment in which disease cannot really get hold of that individual. So it is about, these are dashboard lights that we need to see green as much of the time as possible. What we also need is community-based health systems that exist outside the existing structures that are reactive systems that can engage in proactive healthcare. In many respects, the model that conventional medicine has to have a generalist that defers to specialists is a great concept, but it isn't when the specialists work in individual silos that don't see the whole system, that all speak different languages. So we've developed a community-based health system model that allows the individual to be in control of their own health, to have sight of how their function across 12 domains is working, to share that information with both generalist and specialist practitioners, or health guides as we call them. Really important in this is to ensure that there is a system of shared values, goals and priorities, that the science that underpins these decisions is properly independent of its funding sources, is fully transparent, and that we can move towards some kind of scientific consensus, and that there is public cooperation and support, that there are private-public collaborations and corporations that don't act in their own interest but operate with purpose, and there is a movement towards that even with some of the bigger corporations today, and that government policy works in the interest of constituents, not in the interest of itself and a few large corporations. So we've got a lot of information about this on our website. If you go to anhinternational.org, you'll also be able to see our great Health Reset program, which contains all the information on our blueprint for health system sustainability. So I want to just finish off by saying we have to think big. We have to think about ecological systems and ecosystems. We have to think about the underlying terrain, not only of the individual, but of the planet as a whole. And we've got to be thinking about how these interactions occur and what we can do to make them more favorable. And that means working with nature, not against it. Thank you so much.